example 1 says, refer to this figure to find the measures of angles 1, 2, 3, and 4. Okay, so we need to figure out what angle 1 equals, what angle 2 equals, what angle 3 equals, and what angle 4 equals. Well, the first one that I see is going to be the easiest is angle 2. Okay, because I look right here, and this angle's 40 degrees, and I know that angle 2 has to be 40 degrees. Do you remember what kinds of angles angle 2 and this 40 degree angle are called? Those are opposite angles, or vertical angles. Okay, they're across from each other, and we know that those have to be equal to each other. So angle 2 has to be 40 degrees. Okay, because it's across from the 40 degree angle. Okay, I should also be able to figure out angle 1. Okay, angle 1 and angle 2 are right next to each other. They're adjacent, and we know adjacent angles always add up to 180 degrees. So if angle 2 is 40 degrees, okay, like we said it was, then angle 1 has to be 140 degrees, because it's got to be 180 minus 40, which is 140 degrees. Alright, well, angle 3, we know that angle 2 is 40. We know this one is 90, so angle 3 has to be 40 plus 90, which is 150, and we take that from 180, okay? So angle 3 has to be 180 minus 90 minus 40, okay, which is 30 degrees, because 180 minus 90 is 90. Sorry, that's 50 degrees. My fault. Mr. Ayers messed up on his math. Sometimes that happens, but we fixed it. So again, 180 minus 90 is 90, and 90 minus 40 is 50. Okay? Again, we know that because all the angles in the triangle have to equal 180 degrees. Well, if we know angle 3 is 50, we can figure out angle 4 because they are adjacent angles again. And adjacent angles, ones next to each other, have to add up to 180 degrees. So it's going to be 180 minus the 50 that we had for angle 3. And that's 130 degrees. Again, we got that from using all of our congruent angle relationships that we just discovered. Alright, let's go on to the next slide, another example. So what you'll notice on these is that on the last slide you should have noticed that we knew one angle to start with, and we were able to figure out all the other angles just because of that one angle and the angle relationships that we just learned. So that's going to be the same way here. Okay, so this says parallel lines P and Q are cut by the transversal T. It says the measure of angle 8 is 55 degrees. So we should probably fill that in. We want to know what are the measures of angles 1 through 7. Okay, so I want to know angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, and angle 7. Because I already know angle 8 is 55 degrees. Well, let's start using our angle relationships, okay? We should be able to figure out angle 1 if we know angle 8. Do you remember what kind of angles these are called? When they're both on the outside of the parallel lines and on opposite sides. So one's on top, one's on bottom, and one's on the left and one's on the right. And then they're outside the parallel lines. Those were called alternate exterior angles. And we know that alternate exterior angles have to be equal to each other. So angle 1 equals 55 degrees. Because angle 8 does, and those are alternate exterior. Okay? Well, if we know angle 1, we should also know angle 4, because you remember what kind of angles these are called when they're across from each other like this? These were called opposite or vertical angles. So if angle 1 is 55 degrees, angle 4 has to be 55 degrees as well. Okay, and the same thing, angle 5 here has to be 55 degrees because it's an opposite angle with angle 8. Sorry about the dryer buzzer there. Okay, so we figured out 4 of the angles just without having to really do any math. or sorry, 3 of the angles. Okay, and just by knowing one of them. Well, now we should be able to figure out the rest of them pretty easy. Okay, well, I know that angle 1 and angle 2 are adjacent angles. They are next to each other, so they have to add up to 180 degrees. So angle 2 has to be 180 minus 55, which is 125 degrees. Okay, and we'll start putting boxes around all of our answers here. Okay, so this has to be 125 degrees. And if that one's 125 degrees, then angle 3, which is across from it, vertical angles, opposite angles, has to be 125 degrees as well. Okay, and I could also figure out angle 6 now, because angle 3 and angle 6 are the same kind of angles. Do you remember what pair those are called? When they're inside the parallel lines, they're on the interior and on opposite sides. Okay, these were alternate interior angles, and those were always equal to each other. 125 degrees. And if angle 6 is 125 degrees, we know that angle 7 has to be 125 degrees because they are opposite angles. Okay, so I want you to look at all our answers here. We got the same two numbers for every single angle. Okay, we either got 55 degrees or 125 degrees. And that's how almost all of these problems should work. Okay, especially when you see one like this where you got two parallel lines cut by a transversal. Okay, all the angles should be one of two measures. Okay, you should only see two numbers throughout the whole thing. Okay, and we should have 4 of each one. So we have 4 55-degree angles and 4 125-degree angles. And again, that always holds true whenever we got two parallel lines cut by a transversal. And let's go to our final example. Alright, now we're on to example 3. I really kind of like this example because it's a real-world application to all this stuff. Okay, it says structural engineers, people who design structures, okay, design triangles into buildings, bridges, and towers because triangles are rigid. Rigid means they're really strong and they don't bend very easily. It says the sides of triangles do not shift when force is applied like the sides of quadrilaterals do. So these triangles, like if we push on this point and we pushed against it, it wouldn't bend very easily. You'd have to apply a lot of force. It says a railroad bridge built with a steel truss is strengthened by triangles that keep the bridge straight under the weight of a train. Okay, so a steel truss is this thing right here, and they put triangles underneath it to strengthen it. Okay, if we didn't have all these triangles and it was just a straight line, you don't need to draw this, but if it was just straight lines that look like this, and we put force on this and pushed down on it, it would bend very easily. Okay, so we put triangles on the inside to strengthen it up. So anybody who's going to be an engineer, this is a good thing to know, and you're going to have to know a lot of this stuff. This says, knowing one acute angle in the truss is sufficient to find all the measures of all the angles. And we want to find the measures of these angles. And it says segments that look parallel are parallel and segments that look perpendicular are perpendicular. So what that means is that this big segment here and this one down here are parallel to each other. These are parallel. Okay? This segment and this segment are perpendicular. They make a 90-degree angle. Alright, so again, if we know just this angle right here, we should be able to figure out every other angle in this thing. Alright, which is really helpful when you're building something. So it says find the measure of angle ABF. So we want the measure of angle ABF. Okay, and ABF is this one right here. Well, I know the angle ABF has to be 40 degrees. Okay, because look at this. If this one's 40, we have two parallel lines cut by a transversal, remember? And angles on the inside of the parallel lines and on alternate sides of the transversal. So we got one on the right side, one on the left side, okay, one on top, one on bottom. Those are alternate interior angles. They are equal to each other. Okay, so it's got to be 40 degrees because it's alternate interior. Then we need to find the measure of angle FBC. Alright, and FBC is this one right here. Well, we just found out this one is 40 degrees, and angle ABF and FBC are adjacent. They're right next to each other. Okay, this one and that one. So they have to add up to 180. So that's going to be 180 degrees minus 40 degrees, which is 140 degrees for that one. Because they're adjacent angles, they're right next to each other. And then lastly, we need to find the measure of angle FGB. Okay, and angle FGB is this one right here. Okay, well they told us segments that look perpendicular are perpendicular. Okay, so we have a line right here and a line going straight up from it. That means that it's perpendicular lines. Since that makes a right angle, it has to be 90 degrees. Okay, if it looks like a right angle, it is a right angle. They told us that already. And there's the measure of all three of those angles. Alright, now remember, it's probably going to help you a lot to use your notes on this, so I would keep them out when you're doing your assignment. If you have any questions, ask. Otherwise, happy homeworking.